So, have you ever wondered what makes a scientific study a big hit? Is it that it's a truly groundbreaking, world-changing discovery? Or is it something else entirely? Today, we're going to unpack the hidden rules of what makes research successful. We're diving deep into a massive study that asks a pretty shocking question. To get famous in science, is it better to be right or just popular? All right, here's our game plan. First, we'll look at science's ultimate rulebook. Then we'll see if those rules even change the results. After that, we'll uncover what really makes research famous, how popularity can actually trump scientific power, and why big new ideas often lose out. And finally, we'll ask a tough question. What do we as a society really value in science? Okay, first up, science's ultimate rulebook. To really understand the game, we have to know about the gold standard. We need to look at the single most powerful tool that scientists use to decide what is and what isn't scientific truth. And that tool is called the meta-analysis. It's really cool. Instead of just relying on one single study, a meta-analysis gathers all the research on a topic and uses statistics to boil it all down to one powerful conclusion. So it's not just another study, it's like a super study. The conclusions become the official state of the science, and these papers get cited almost 3 times more often than normal ones. Bottom line, they are a very big deal. And the scale of the research we're looking at today is just massive. The researchers behind it analyzed 196 of these super studies, which covered over 5,500 distinct scientific findings. And this was all published over 27 years in top journals. So what we're getting is this incredible panoramic view of how science really works. So this brings us to a huge debate within the scientific community. For years, there's been this nagging worry that scientific findings are, kind of fragile, that all the little judgment calls researchers have to make could totally change the final answer. Well, today, we're going to put that idea to the test. Okay, so here's the core question. Critics worry that these different judgment calls could lead to wildly different results. And that kind of makes sense, right? Different choices should lead to different outcomes. But what does the data actually say? And boom, right away, we get our first big surprise. Here, the researchers measured the strength of a scientific finding. They call it an effect size. And look, whether they decided to exclude some studies from their analysis or not, the result barely budged. It went from a 0.25 to a 0.26. On the grand scale of scientific impact, that difference is basically zero. And that wasn't just a one-off. The study looked at 21 different methodological choices a researcher could make. And when you add them all together, all those choices accounted for just 0.7% of the difference between scientific results. Let me say that again, less than 1%. All that debate, all that anxiety, and in the end, it barely moves the needle. So the big takeaway here is that scientific findings are actually incredibly sturdy. They aren't easily thrown off course by all the little decisions researchers make along the way. And honestly, this is fantastic news. It means the core truths that science uncovers are pretty darn reliable. But this leads to a new and I think way more interesting question. If all those little choices don't really change the result of the science, then what do they change? What are the consequences of taking one path over another? Well, the answer takes us away from scientific truth and brings us straight to scientific fame. So, how do you measure success in science? Well, it's not just about being right, it's about being cited. A citation is when another scientist references your work in their paper. So the more citations you get, the more influence you have, the more prestige. Citations are, quite literally, the currency of the academic world. And this brings us to where the story gets really juicy. Popularity trumps power. We've just established that all those methodological choices don't really affect a finding's scientific power. But what about its popularity? What about its citations? Okay, let's take the choice of what statistical software to use. This was actually one of the few choices that did have a noticeable impact on the result. One software gave an effect size of 0.18, another gave 0.35. That's a real difference. But now, let's see how that same choice affected citations. And here is where your jaw drops. It's a massive difference. Using the more popular Hunter-Smith method didn't just tweak the result a little bit. It generated almost 28 citations a year. It just blows the others out of the water. Simply by following the in crowd and using the popular tool, a study's visibility went through the roof.
This whole phenomenon actually has a name. It's called particularism. See, in an ideal world, science is a universal system where the best ideas with the strongest evidence always win out. Particularism is the opposite. It's when research gets judged on other stuff, like whether it comes from a famous university or if it just uses a popular, trendy method.
And this leads to maybe the most powerful and kind of depressing finding of the entire analysis. The researchers asked a simple question. Did stronger, more groundbreaking results get cited more often? And the answer was a flat no. Just think about that for a second. The actual scientific power of a discovery had no relationship to how famous it became, but using a popular method did. But the story doesn't stop there. There's one final, surprising twist that reveals an even deeper bias in the system, one that works against the very thing science is supposed to be all about: discovery. So the researchers categorized every study by its goal. Was it trying to build a brand new theory? Or was it just testing a theory that already existed? And what they found was this incredible trade-off. The studies that were trying to build new theories, they actually found stronger scientific results. Their effect sizes were bigger, but they got fewer citations. Meanwhile, the studies that played it safe and just tested old established theories, they found weaker results, but they got way more citations. The takeaway here is pretty stark. It really seems like science rewards conformity. New ideas, even when they have stronger evidence backing them up, are just less likely to get noticed. It seems that even in the world of research, it can be a lot safer and a lot more rewarding to just stick with what's familiar. So let's bring this all home. We've learned that the scientific results themselves are pretty solid, but fame is all about popularity and conformity. What do these hidden rules tell us about what science, as a system, truly values? All right, so here's the whole story we've just uncovered. The good news? Scientific findings are solid. That's great. The kind of cynical news? A study's fame is driven by popular methods, not by powerful results. And the most troubling part? The system actually rewards confirming old ideas over discovering new ones, even when those new ones are backed by stronger evidence. And this leaves us with a really critical question to think about. We rely on science to push the boundaries of knowledge, to make that next great leap forward. But if the very culture of science, the whole system of rewards and recognition, prefers what's safe and familiar over what's bold and new, what does that mean for the future of discovery? It suggests that the biggest barrier to progress might not be the complexity of the universe, but the sociology of science itself. And why this matters is simple. A system that rewards conformity over discovery risks slowing its own progress to a crawl, and that's a thought really worth thinking about.